Lunar talk to us about lunar exploration from the ESA perspective. Thank you.
Okay, so thank you. While I'm waiting for my slides, I'll get started. So for those of you who don't know me, I'm James Carpenter. I'm from the Lunar Exploration team in the European Space Agency. We're in the Directorate of Human Spaceflight and Operations, based at ESA ESTEC in the Netherlands. And what I wanted to do this afternoon was to give you, I guess, a quick overview of the context for lunar exploration in ESA, of some of the activities that we have running at the moment, some of what we're looking to try and do in the future, and to kind of give you a flavour of what ESA's vision for what lunar exploration could be in the kind of the coming decades. That'll be a lot easier when I've got some slides to show you.
Please stand by.
Okay, thank you. That's okay. Yeah, my slides are definitely in there somewhere. Yes, because it's got a movie embedded in it. So. That's it.
Okay, so this is what's happening. He has this wonderful movie he's going to show us, and it's taking a while to download it. So something I was going to say later that I'll just say now. If you had a poster here, or if you know of students that had a poster here and maybe they're already gone, if they could send us the PDF file of those posters, we will put that up on the website along with the archive of all the talks. And people have been asking us for that today, and I realized I don't think we ever asked anybody to give us those files. So we sent a note out, but you could also remind them while they have it handy, maybe they could just go ahead and send it on to us here at Survey Central. Oh yes, okay, the Survey Monkey, Survey Monkey. Okay, we have a survey at the end of the forum every year, and so we'd like to ask you to please take a moment and fill that in for us. We'll be sending you the link, but it will also be up here on a slide after all the talks that we have in this session. So, anything else? Oh, okay, yes, you are free to take your posters down now. Okay, we have already made the decisions. We will tell you the results soon. Come on. Can you dance?
I can learn. I have time to learn, perhaps.
Well, I can also say that I've been really pleased with the comments that so many of you have given, I think, to many of us, but I know for me personally, you've come up and said that the content with this forum was even better than the other ones, and you thought the other ones were pretty good. So I think that's testimony to the great speakers and the wonderful topics, but also I think to time going by and the missions and the analysis of the data maturing and things coming together now in exactly the way that we had hoped for and envisioned, that we would have science and exploration really working hand in hand. And I think this is the forum where we've been able to see that first in such depth. So I'm really excited about that. And I believe that the legacy of what we have done here in the last couple of days will live on, and this will be the forum that people will go back and look at those archived talks and learn more from them than they had even while they were here. I know I will.
So I'll go without slides. I'll go without slides.
Okay.
They'll turn up. It'll be fine. Okay. So lunar exploration in ESA, as I mentioned, I'm from the Human Spaceflight and Operations Directorate, and so lunar exploration has really been seen in the context of future human exploration. So a lot of our work is in the frame of the ISEG and the Global Exploration Roadmap, and in that roadmap I think we have all these different agencies from around the world who have a common understanding that the destination we all want to get to is Mars. We want to put humans on Mars. But for ESA, the stepping stone on the way to Mars is the Moon, and the Moon is the place which is the next destination for human exploration after low Earth orbit. This is kind of the way that ESA see things. And so we're making efforts to try and to enable human exploration of the Moon, and to get to the Moon, to put Europeans on the Moon as part of a broader international exploration program. So if one looks at the global exploration roadmap, there's a line in that roadmap for lunar exploration, and a sequence of missions that have been identified. And this starts off with robotic precursor missions, which should go to the surface to perform basic research, to demonstrate technologies, to generate new knowledge that's enabling, and to perform science. The next phase after that would integrate humans and robotic explorers together, working together at the surface to deliver science, to prepare for the next steps, with the goal of having humans at the surface sort of 2030 kind of time frame. Now, something that we've learned from experience is that within Europe, we're not going to lead this. We're not going to be able to do this on our own. This is something that's only going to happen as part of a broader international collaboration between multiple agencies. And so the approach for ESA has been to identify core areas where we think we have a competence, and where we have a heritage and we have capabilities and where we have an interest, and to try and focus on those areas. And so we're developing some core exploration products and core exploration capabilities that we can then bring to missions with international partners to be enabling for those missions and to be on the critical path of those missions, to set up the roles that ESA would have in those future human missions, and to secure a place there. And so the first part of that will be to work with Russia. So we are working at the moment with Russia on their lunar exploration program. Now, they have a very ambitious program of robotic exploration of the Moon. This starts with the Lunar 25 mission, which is a lander, sort of a technology demonstration lander, then the Lunar 27 mission, which is an orbiter, Lunar 26, and then Lunar 27, which is a second lander. The second lander would be larger, would have a higher payload capability, a greater science return capability, and this is where we're really focusing our efforts at the moment. So yesterday I presented Prospect, which is a drilling, sampling, sample analysis end-to-end chain, which you would look to include on that mission. But we're also looking to include precision landing capability and hazard avoidance capability to that mission, and also to provide communications support and ground station support for that. We're also providing some lower level contributions to the earlier missions, but this is where the focus is at the moment. And we're preparing the Phase B activities for those activities now, with a view to kicking those off towards the end of this year. Now, those should then go forwards into the next big mission in the Russian program or Russian plans, which is a lunar polar sample return mission. And the idea for this is to return frozen samples from the lunar polar regions and to bring those back for analysis on the ground in terrestrial laboratories. And for this mission, we'd be looking to provide a larger contribution. So rather than providing small parts of a Russian mission, this would really be much more of a collaborative effort with ESA contributing at system element level. So this is kind of the robotics train of what we're doing, identifying sort of core capabilities, bringing them to an international partner with a view to demonstrating and building up those capabilities for future missions. So in parallel with that, we also have a kind of a human element. So the beautiful picture that I would have shown you of would be of the Orion and its service module. And so ESA is providing the service module for the first Orion flights. And so this puts ESA on the path of human transportation. And this is actually a first for Europe to be on the critical path for human transportation. And that's kind of a big deal, and so which is, I think, very important strategically for Europe. And so we have this robotic and surface access train in parallel with a human capability. And the idea is that sometime in the 2020s, these two things come together and we can really integrate human and robotic exploration. And so we have a study which is going on at the moment, led by ESA, but with international partners through ISEG, into a mission architecture called Heracles. And the idea of Heracles is that it would use a deep space habitat, which is crewed, coupled with a robotic surface element. Wonderful. Which is coupled with a robotic surface element, which could rove around, which can be teleoperated from the station, from this deep space habitat. And that this robotic capability, so you see these are all the missions in ISEG. We have and also worth mentioning, the ESA space exploration strategy was published I think earlier this year and can be downloaded. And this sort of identifies these strategic roles, and international partnerships is the way that it's going to be done. And just to give you a bit of the context of that, at the end of last year, at the Ministerial Council for ESA at the end of last year, a mandate was given for ESA to begin lunar exploration preparatory activities in the context of the ISS program. And so that is what we're doing now, and so the things I'm talking about are all being done sort of through that area. So here we have the Russian missions, the Lunar 27 and Lunar 28 sample return mission. The areas where we're going to be contributing to these missions and the way this kind of builds up incrementally in terms of the level of capability. Orion, which you all know. This is Heracles. So Heracles has a combination of the crewed deep space habitat, surface robots, which should enable sample return. At the same time, should prepare capabilities, operational experience, technologies and scientific knowledge for future human missions. And it should also deliver science. So this is something which is being studied with international partners to try and sort of see the way that we can, to try and identify roles and ways that we can pull these kind of different capabilities together in the interests of different international partners within ISEG. So before we just start this movie, this is a movie which it's intended just to give you a flavour of where we think that lunar exploration can be over the coming decades and what it's for. And it's intended for a broad audience, but I'll try and give you a flavour of what it's about. If we could start the movie. Cool. There should be some audio. Okay. So of course, so we start by, of course, we have to look back, and the 1960s and 70s was, of course, the golden era of lunar exploration, where, of course, we had the Ranger missions from the United States, which took close-up images of the surface of the moon before impacting into the surface, and this really marked a fantastic start for the US space program. And then Surveyor, which demonstrated a soft, controlled landing at the surface of the moon and measured the properties of lunar regolith to prepare for future human missions. And then, of course, there are our friends in Russia and in the work of the Soviet Union, who made multiple landings at various sites, roving around the surface and returning samples back to Earth. But the pinnacle of this period of exploration was, of course, Apollo, and the arrival of humans at the surface of another solar system body for the first and the only time in history. But when we look back now, we realise that only a tiny fraction of the lunar surface has been explored, all on the near side, all near the equator, and really covering a tiny fraction of what we need to see to understand. But we also now know that all of the samples that we've returned to Earth come from a region which is quite unique on the surface of the moon, as a kind of an exotic chemistry of potassium, rare earth elements, and phosphor. So what we can say for certain is that if we want to really understand the moon, then we need to go back there. So now, after decades of waiting, an armada of international missions has returned. So led by various missions. So we had the ESA Smart 1, we've had missions from Japan, from China, and from the USA. And what these have done is really given us a global view of the moon. They've transformed our understanding of what we thought we knew about the moon from these earlier missions, and have really changed the way we understand it, and really revealed the need to go back to the surface. And so when we think about the missions that are going to come next, which are going to go back to the surface, where do we think they're going to go? We would suggest that probably the place these missions are going to go will be the lunar South Pole. Now, the lunar South Pole, we know, is quite unique in that it has these extraordinary regions of permanent darkness and extreme cold. These are places where volatiles and other water ice can become trapped. And as we come up from these lowlands, we can see towering peaks which are basked in near eternal light. Now, these places offer an opportunity for near permanent illumination and solar power, as well as offering a fantastic view of this sort of rugged, cratered and quite awesome landscape beneath us. Now, in 2009, the L-Cross mission impacted into one of these permanently shaded regions and threw water and other volatiles out of this crater so that nearby spacecraft could observe them. And this was really the first time that we really had sort of categoric proof that there was water down there, and ignited international excitement for what could be done with this and the opportunities that this thing offered. But we also now know that there are nearby regions with similar cold conditions. And so we ask ourselves, is there water here too? How much is there? Where does it come from? Can we use it? And what can it tell us about water and life-enabling chemistry on our own planet? Now, it could be that this water has been delivered by comets and asteroids impacting into the surface of the moon over billions of years. It could also be that this water has been created at the surface of the moon. So we now know that protons thrown out by the solar wind impact into the surface of the moon, where they create water. And this water can be heated by the sun, it can lift off the surface, and it can hop towards the poles, where it become trapped by the cold conditions there. But as we stand at the surface, next to this water, next to the cold, we can turn our telescopes to the sky and our radio antennas to the sky to look for radio sources deep out in the cosmos. But we have a problem, because the Earth is in view and the noise from the Earth is too loud. It blocks out these faint signals. But if we move just back from the pole so the Earth slips out of view, the noise disappears, the sky goes quiet, and a new kind of radio sky emerges in long wavelength radio. So now we can see the galaxy, and we can see the planets as never before. And behind it all, there's a quiet radio hum, the 21 centimeter hydrogen line from the cosmic dark ages, and 13 billion years ago, when the first cosmic structures were formed. And so now if we look down at the moon from above, as we see it today, we see a surface which has been scarred and pulverized over billions of years by impacts. And the largest and most ancient of these impacts is the South Pole Aitken Basin. So formed by an impact around 4 billion years ago, this feature marks the start of a period which many believe happened with the cataclysm, when the entire inner solar system was pulverized, including the Earth. Now this era is recorded on the surface of the moon, and in order to understand it, we need to go back there. So in the coming years, we will see lunar explorers at the surface of the moon again. Now this will start with small robotic missions, which will be looking for resources, making measurements of the environment, trying to understand our place there, proving technologies, and really preparing the way for the missions that will come next. Now following these missions, we'll move on to increasingly complex missions where humans and robots are working together, performing important research to improve life on Earth and to inform our understanding of the moon and the solar system, and to prepare for the next steps too. Now, an important thing about these missions is that they won't be formed in competition as before, but through peaceful international cooperation. And so eventually, what we will see is a sustained presence at the surface of the moon, where we'll have bases akin to the kind of place that we would see in Antarctica today, building on the experience of years on the International Space Station, and using this to learn how to live and work off planet, and to prepare for the next steps of human exploration. So we think that the moon can become a place where the nations of the world can work together, to learn how to proceed together, to take onward steps together, and to understand our common origins and what it is to explore and work together to a greater purpose. And perhaps in the future, at the edge of a crater, next to the cold, in the presence of water, we'll learn to understand how to access and utilize resources from deep below in the dark. So here we see water trapped in the cold, hydrogen and oxygen, which are of course essential for sustaining human life, but they're also rocket fuel. fuel which we can use to power ourselves, beyond the moon, to Mars, and to the next destinations on our journey together into the cosmos. Thank you. Cool. So just to finish, my last slide. Thank you. So we're planning a workshop at ESTEC on the 15th and 16th of December, right before Christmas, just the time you want to go and visit the Netherlands. And the workshop is it's going to be entitled Moon 2020 to 2030, a new era of coordinated human and robotic exploration. And the idea of this workshop is to talk to the community about what the community thinks this era is going to be about, what the requirements for this will be, where the benefits will be, and just to kind of highlight some of the really key science and technology aspects of what's going to come during the next decade. And that's it. I'm done. Thank you.
Thank you so much. I was just going to say that was as poetic as when Carly gave her wonderful
Can't compete with Carly.
I don't know. That's pretty great. What great delivery. We have a question or a comment, probably.
Hi, James Jack Burns.
Hi,
I like your presentation. I like the vision. I personally agree with it, but just last week I was at NASA headquarters, and whenever I talk about going back to the surface of the moon, I get this hazy look from their eyes and a strong pushback saying, if we go back to the surface of the moon, establish some of the infrastructure that you were talking about, we'll never get to Mars. And there's this attitude that permeates within at least part of NASA now. So how do you think we can get beyond that? Because I do agree very much with you that going to Mars is going to be through the moon, but there is this perception that the moon will just prevent us from ever getting to Mars.
I don't know what domestically you can do to affect the opinions of decision makers, and that's I wouldn't want to comment. Certainly, I feel that we're very blessed in ESA that this is a vision that I think we have in ESA to go to the moon next, and that the understanding that it's what we learn on the moon and the using that as a place to develop technologies and to learn that's going to be enabling for that Mars trip. But also it's something that we can do in a timescale that is meaningful in terms of people's careers, for example, which is, and I think that's an exciting thing to be involved with. I think it's a big challenge, and it's again a big challenge. It's going to be done internationally, and certainly the impression that I get from ISEG is that internationally, there's, for the most part, most agencies would agree that this is what they want to do.
Yeah, let me add a little bit to what Jack said. I don't think logic is going to work as far as the moon in place of Mars or something like that. I think what got us to the moon, it was a Cold War. Maybe this Cold War can start again. And there could be some good points to that, okay? The fact is, it's right on the brink. It could happen. NASA has various types of rules and laws where we cannot collaborate with the Chinese right now. But the fact is, it may get a little bit bigger. So I think there's more hope there than there is through logic.
Thanks a lot.
I'm not going to let the forum advocate that we start a Cold War, okay? not going to do that, but we understand the sentiment behind what you said, Larry, very much, and I think many people in this room agree.